So good morning Andy. So today topic is eigenvalues and eigenvectors. So characteristic matrix. For a given matrix A, the matrix A minus lambda I is called the characteristic matrix, where lambda is a scalar and I is the identity matrix. For example, A equal to first row 2, 2, 1, second row 1, 3, 1, and third row 1, 2, 2. So this matrix, to find characteristic matrix. So current definition, A minus lambda I. A minus lambda I equal to A matrix is 2, 2, 1, 1, 3, 1, 1, 2, 2 minus lambda I is the identity matrix in 3 by 3. 1, 0, 0, 0, 1, 0, 0, 0, 1. That equal to 2 minus lambda. 2 minus 0, 2, 1 minus 0, 1. First row completed. Second row 1, 3 minus lambda, 1, and third row 1, 2, 2 minus lambda. This matrix is the characteristic matrix. A minus lambda equal to 2 minus lambda, 2, 1 first row, and second row 1, 3 minus lambda, 1, and third row 1, 2, 2 minus lambda. So next definition is characteristic polynomial. The matrix theta of A minus lambda I, when expanded, will give a polynomial which we call as the characteristic polynomial of the matrix A. Just to go to expanded, theta of A minus lambda I matrix. For example is, just last example, theta of 2 minus lambda, 2, 1, 1, 3 minus lambda, 1, 1, 2, 2 minus lambda. Just would expanded to find characteristic polynomial lambda cube minus 7 lambda square plus 11 lambda minus 5. Just would expanded, and first row 2 minus lambda, first row first column 3 minus lambda into 2 minus lambda minus 2, minus 2 into first row second column, right, 2 minus lambda minus 1, and plus 1 into first row third eliminating 2 minus 3, 2 minus 3 plus lambda expanded. Then go to final equation is lambda cube minus 7 lambda square plus 11 lambda minus 5. Therefore, this is a characteristic polynomial of the matrix. So next definition is characteristic equation. The equation theta of A minus lambda equal to 0 is called the characteristic equation of the matrix A. Just to go to theta of A minus lambda equal to 0 is known as a characteristic equation. For example, last example, just go equal to 0. Lambda t minus 7 lambda square plus 11 lambda minus 5 equal to 0 is known as a characteristic equation. So next definition is characteristic roots are eigenvalues. Definition is the roots of the characteristic equation theta of A minus lambda equal to 0 are called characteristic roots or eigenvalues of the matrix A. Right? For example is lambda cube minus 7 lambda square plus 11 lambda minus 5 equal to 0. So by using, so here division, first coefficient lambda cube coefficient is 1, lambda square coefficient is 7, lambda coefficient is 11, and constant minus 5. Just to verify that, first 1, 0, 1, 1, 1 are 1, minus 6, 1 into minus 6, 5, that equal to minus 5 plus 5 is 0. So first root is lambda equal to 1 root, and next one is lambda square. Next equation is lambda square minus 6 lambda plus 5 equal to 0. Right? Lambda square minus 6 lambda minus 5 lambda minus lambda. Lambda square minus 5 lambda minus lambda plus 5 equal to 0. Lambda is one element common. Lambda into lambda minus 5 minus 1 is the common. Lambda minus 5 equal to 0. Lambda minus 1 into lambda minus 5 equal to 0. right? Lambda equal to 1 comma 5. Therefore, characteristic roots are lambda equal to 1 comma 5. So next definition is eigenvectors. A non-zero vector capital X is said to be an eigenvector of a matrix A. If there exists a scalar lambda such that Ax equal to lambda x, a non-zero vector capital X is said to be an eigenvector of the matrix A. If there exists a scalar lambda such that Ax equal to lambda x. So next definition is to find eigenvector procedure. To find eigenvectors, let A equal to Aij be an n by n matrix. Let x be an eigenvector of A corresponding to eigenvalues lambda. By the definition, Ax equal to lambda x, Ax equal to I into lambda x, Ax minus lambda I into x equal to 0. Here x is the common, A minus lambda into x equal to 0. This is to find the eigenvectors, A minus lambda into x equal to 0. Right? For example, find the eigenvalues and corresponding eigenvector of the matrix A equal to. First row is minus 2, 2, minus 3, and second row is 2, 1, minus 6, and third row is minus 1, minus 2, 0. Right, the answer. First one, given the matrix A equal to, first row is minus 2, 2, minus 3, 2, 1, minus 6, minus 1, minus 2, 0. Step number 1 is to find eigenvalues. To find eigenvalues. So procedure is the characteristic equation, the characteristics equation of A is that of A minus lambda I equal to 0. Right? So data of minus 2 minus lambda 2 minus 3. So 2, 1 minus lambda minus 6, minus 1, minus 2, 0 minus lambda equal to 0. Right? Then go to expand it. So minus 2 minus lambda into first column. Right? 1 minus lambda into minus lambda. Minus lambda minus plus lambda square. Right? Minus plus minus 6 2 jar 12, minus 12. Next one is minus 2 into first or second column, right? Minus 2 lambda, minus plus minus 6. Plus into minus 3. First or third column, minus 4 minus plus 1 minus lambda equal to 0. Right? Just expanded. Minus 2 minus lambda, right? Lambda square minus lambda minus 12. Minus 2 into minus 2 lambda minus 6, right? Minus 3 into minus 4 plus 1 minus 3 minus lambda equal to 0. Right? Minus 2 multiplying minus 2 lambda square minus minus plus 2 lambda minus minus plus 24, 12 to 24. Next minus lambda multiplying minus minus lambda key minus minus plus lambda square minus minus plus 12 lambda plus 4 lambda minus minus plus 2 6 are 12 plus 9 plus 3 lambda equal to 0. Right? First one highest coefficient degree is minus lambda key. Minus lambda key, what lambda square? Minus 2 lambda square, lambda square minus lambda square. What of lambdas? So 2 lambda plus 12 lambda, 14 lambda, 14 lambda plus 4 lambda, 14 lambda plus 4 lambda, 18 lambda, 18 lambda plus 3 lambda plus 21 lambda, 21 lambda. What constants? 24, 24 plus 24 plus 12, 36, 36 plus 9 plus 45 equal to 0. Right? Minus multiplying lambda key plus lambda square minus 21 lambda minus 45 equal to 0. Right. To find the roots, by using calculator division. First coefficient is lambda cube coefficient is 1. Next lambda square coefficient is 1. Lambda coefficient is minus 21 and constant coefficient is minus 45. Just look at that 5. Right? 1, 5 1 jar 5, 5 plus 1 6, 5 6 jar 30, 30 minus 21 9, 5 9 jar 45 plus 45 minus 45 0. One root is lambda equal to 5 one root. Next equation is lambda square plus 6 lambda plus 9 equal to 0. 6 lambda nothing but 3 lambda plus 3 lambda, lambda square plus 3 lambda plus 3 lambda plus 9 equal to 0. Right? Lambda is the common, lambda plus 3 is the common plus 3 3 just 9. Right? Lambda plus 3 into lambda plus 3 equal to 0. Right? Lambda equal to minus 3 comma minus 3. Therefore, lambda equal to minus 3 comma minus 3. Therefore, eigenvalues capital A are lambda equal to 5 comma minus 3 comma minus 3. First part is over. First part to find eigenvalues completed. Next one to find eigenvectors. Step number 2 is find eigenvectors. Right? So case 1 is if lambda equal to 5. What procedure? Consider a minus lambda I into x equal to 0. What A minus lambda matrix and A minus lambda matrix is minus 2 first row minus lambda 2 minus 3, second row 2 1 minus lambda minus 6, and third row minus 1, minus 2, 0 minus lambda, minus lambda. A minus lambda. Next multiplied column unknowns. x1, x2, x3 that equal to 0, 0, 0. Right? Lambda equal to 5. Substitute lambda equal to 5. So this matrix is minus 2 minus 5 minus 7 2 minus 3. So second row 2 1 minus 5 minus 4 minus 6, right? Minus 1 minus 2 minus 5. Right? Column unknowns x1, x2, x3 that equal to 0, 0, 0. This reduced to echelon form. Echelon form only row operations. First column, second element, third element 0 by using R1. Right? Applying R2 gives us to 7 R2 plus 2 R1. R3 gives us to 7 R3 minus R1. Right? So this matrix is first we saying minus 7 to minus 3. Right? 2 into R7 R2. 7 into R2 value 2. 7 into 14 plus 2 into R1. 2 into minus 7. Right? 14 minus 14 0. And next one is 7 4 jars 28 minus 28 minus 28 plus 2 into R1 minus 28 plus 4 minus 24. Next one is 7 into R2. 7 6 jars minus 42 minus 42 minus 2 into minus 3 minus 42 minus 6 minus 48. Third row is 7 R3 minus R1. 7 into minus 1 minus 7 minus R1 value minus 1 minus minus plus 0. 7 into R3 minus 14 minus 14 minus 2 minus 14 minus 14 minus 2, I mean minus 16 minus 16. Next one is 7 into R3 minus 35 minus 30 minus 35 minus 35 plus 3 minus 35 plus 3 minus 32 into column unknowns x1, x2, x3 that equal to 0, 0, 0. Right? Next go to applying just multiplying R2 gives us to minus 1 by 24 and applying R3 gives us to minus 1 by 16. Just only second row and third row multiplying. Second row minus 1 by 24 and third row minus 1 by 16. Right? This matrix is first the same minus 7 to minus 3. So applying R2 gives to minus 1 by 4 into R2 minus 1 by 16 into R3. Right? So this matrix 7 2 minus 3 0 second row, right? Minus 1 by 24 into R2 minus plus, this value is 1. 24, 1. Next one is 24 2 jars, minus plus 2. R3 gives us to minus 1 by 16 into R3, 0. Right? Minus 1 by 16 into 6 minus plus, this value is 1. Right. Minus 1 by 16 into minus 32. 16 2 jars minus plus 2. X1, X2, X3 that equal to 0, 0, 0. Right. First column, so first step number 1 is first column, second element, third element 0 by using R1. Step number 2 is second column, third element 0 by using R2, echelon form, right? Applying R3 gives us to R3 minus R2, right? This matrix first row is same, minus 7, 2, minus 3, second row is same, 0, 1, 2, third row is R3 minus R2, 0 minus 0, 0, right? 1 minus 1, 0, 2 minus 2, 0, right? So the here column unknowns is X1, X2, X3 that equal to 0, 0, 0. This echelon form, right? This equation is minus 7x, just to row it column multiplying, minus 7x1 plus 2x2 minus 3x3 equal to 0, right? Minus multiplying 7x1 minus 2x2 plus 3x3 equal to 0, first equation. And second equation is x2 plus 2x3 equal to 0. This is the second equation. Here only two equations, number of unknowns, 3 unknowns, x1, x2, x3 is the unknowns. Just I am taking just only the independent variable, let x3 equal to k. Right? To find x2 value from equation number 2 implies, right? x2 equal to minus 2x3, x2 equal to minus 2k. x2 value, okay, and x2 value to find x1 value from equation number 1 implies, right? 7x1 equal to 2x2 minus 3x3, 3x3, 7x1 equal to, right, 2 into x2 minus 4k minus 3 into x3 value k, right? 7k1 equal to minus 7k, right? x1 value is minus 1. So therefore eigenvector capital X1 equal to small x1, small x2, small x3, that equal to x1 value is minus k, x2 value is minus 2k, x3 value is k. K is the arbitrary constant, that equal to k, the arbitrary constant of minus 1, minus 2, 1. This is the first case, case 1 to find eigenvectors. If lambda equal to 5, eigenvector x1 equal to minus 1, minus 2, 1. Right? And case 2 is if lambda equal to minus 3. What procedure? Consider consider A minus lambda I into x equal to 0, right? So even lambda matrix is minus 2 minus lambda 2 minus 3 first row, second row 2 1 minus lambda minus 6 and third row minus 1 minus 1 minus 2 0 minus lambda and next nothing but column unknowns x1 x2 x3 that equal to 0 0 0, right? Substitute lambda equal to minus 3 in this matrix. Minus 2 plus 3, first one element is 1 2 minus 3, second one is 2, right? 1 plus 3 4 minus 6. And third row is minus 1 minus 2 lambda value minus 3 minus plus 3, right? x1 x2 x3 that equal to 0 0 0, right? So this matrix reduced to the echelon form. Echelon form only row operation. Step number 1 is first column, second element, third element 0 by using R1, right? Applying R2 gives us to R2 minus 2R1, right? R3 gives us to R3 minus 1 plus 1, R3 plus R1. So this matrix is 1 2 minus 3 first row, second row is 2 minus 2 0, 4 minus 2 into 2, 4 minus 4 0, third row is minus 6 minus 2 into minus 3, minus 6 plus 6 0. R3 gives us to R3 plus R1, minus 1 plus 1 0, minus 2 plus 2 0, 3 minus 3, 3 minus 3 0. So this matrix is column unknowns x1 x2 x3 that equal to 0 0 0, right? So echelon form here. First row and column multiplying x1 plus 2 x2 minus 3 x3 equal to 0. This is equation number 1. It is only one equation. Whatever number of unknowns, 3 unknowns, x1 x2 x3 column unknowns. To find two independent variables, let x3 equal to k1 and x2 equal to k2. Why reason here? Here only one equation, 3 is unknowns, 2 is the independent variables, right? From equation number 1 implies, right, x1 equal to minus 2 x2 plus 3 x3, x1 equal to minus 2 into x2 value is k2 plus 3 into x3 value is k1, right? Therefore, eigenvector capital X equal to small x1, small x2, small x3 that equal to x1 value minus 2 k2 plus 3 k1. x2 eigenvector is k2, x3 eigenvector is k1, right? That equal to so k2 is the common, orbital common, minus 2 1 0 plus K1 is the common 3 0 1. Therefore eigenvector x2 eigenvector is minus 2 1 0 and x3 eigenvector is 3 0 1. Therefore eigenvalues of capital A are 5 comma minus 3 comma minus 3 and corresponding eigenvectors x1 equal to minus 1 minus 2 1 x1 equal to minus 1 minus 2 1 x2 eigenvector is minus 2 1 0 and x3 eigenvector equal to 3 0 1. This example is to find eigenvalues and eigenvectors. Thank you.